Good morning all. This is Dr. D. Khalandar Basha, working as Associate Professor in Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today I am going to discuss the IOT levels and deployment templates under the course Principles of IOT. The slides are prepared by referring the textbook Internet of Things, a hands-on approach, authors Akshatdeep Bag and Vijay Madhisetti, publication University Press. In this session, we will discuss the IOT levels and deployment templates, where we are going to define the various levels of IOT system, that is IOT level 1, level 2, level 3, level 4, level 5 and level 6. So, an IOT system comprises of following components. It may consist of a device, a resource, control service, database, web service, analysis component and application. A typical IO system may consist of these blocks. So now we will see the significance of each and every component. The device. So an IoT device allows identification, remote sensing, actuating and remote monitoring capabilities. Whereas the resources, these are the software components on the IoT device. The functionality it is for accessing as well as processing and storing the access from the sensor data and control the actuators depending upon the sense data from the sensor connected to the device. Controller service. The controller service is a native service that runs on the device and interacts with web services. The control services sends data from the device to the web service and receive commands from the application via a web service for controlling the device. So let us consider here we have a sensor. This you are processing, the data may be stored either in the database or it may be stored in the cloud. So whatever the sense data we are having, this will be processed by the processing unit. It may control the actuators which are nothing but the outputs. So the data whichever it is sensing, it will be stored in the database or cloud based. This will be processed depending upon the sense data. It may give the commands to the actuators as well as for sensing. Like let us consider if I have a light LDR where I want to find the intensity of the light from the sun. So for movement of the LDR, we can get the commands to the movement of particular LDR as well as to control these actuators we are going to get the commands. The database, it can be either local or in the cloud, which is used for storing the data which is generated by the IO device. The web services. The web services serve as a link between the IoT device and application, database and analysis components. Analysis component analyzes the IoT data and generates a result in a form which are easy to understand for the user. Application. IoT application provide an interface that the user can use to control and monitor various aspects of the IoT system. Application allow to view the system status and the processed data. Now we will see the IoT level 1. A level 1 IoT system as a single node or a device that performs sensing and or actuation, stores data, performs analysis, and hosts the application as shown in the figure. The level 1 system are suitable for modeling the low cost and low complexity solution where the data involved is not big and the analysis requirements are not computationally intensive. So from this local, we are going to have the application. The application will be connected through communication established by either WebSocket or REST to the web service model. This will store the data or it can fetch the data from the database. Similarly, here we have a monitoring node. This device may be a sensor or actuator or both sensing and actuating. This will get the data for the resources. From here we are going to get the information from the control if it is a sensor. If it is an actuator, from control service to receivers and the devices we are going to get the commands. Now we will see examples for a level 1 IoT system which is for home automation. The system consists of a single node that allows controlling the lights and applications in home remotely. The devices used in this system interface the lights appliances using electronic relay switches. The status information of each light or appliances is maintained in the local database. REST service deployed locally allow retrieving and uploading the state of each light or each appliances in status database. The control service continuously monitor the state of each light or appliances by retrieving the state of the database and triggers the relay switches accordingly. The application which is deployed locally has a user interface for controlling the lights and appliances. Since the device is connected to the internet, the application can be accessed remotely as well. Now we will see level 2 in IoT system. A level 2 IoT system has a single node that performs sensing and or actuation and the local analysis as shown in the figure. The data is stored in the cloud and application is usually cloud based. Level 2 IoT systems are suitable for solutions where the data involved is big. So here the application is running on the cloud, whereas the device, either it can be a sensor or it can be an actuator which is present in the local. So the sense data, if it is a sensor, this will be stored the data into the database or application through this communication channel. Similarly, this if it is an actuator, we are going to get the commands from this WebSocket to the device. Now examples of a level 2 IoT system for smart irrigation. The system consists of a single node that monitors the soil moisture level and control the irrigation system. The device used in this system collects soil moisture data from sensor. The controller service continuously monitors the moisture levels. If the moisture level drops below a threshold, the irrigation system is turns on. For controlling the irrigation system, actuators such as solenoid valves can be used. The controller also sends the moisture data to the computing cloud. So the cloud-based REST web service is used for storing and retrieving moisture data which is stored in the cloud database. So the cloud-based application is used for visualizing the moisture levels over a period of time, which can help in making a decision about irrigation schedules when it has to on these motors for water supply kind of things. Next one is IoT level 3. A IoT level 3 system has a single node. The data is stored and analyzed in the cloud and application is cloud-based as shown in figure. Level 3 IoT systems are suitable for solution where the data involved is big and the analysis requirement are computationally intensive. So here also the structure wise it is same as that of the level 2. Only here mainly it is involved the size of the data is more as well as the computations which it is going to be processed is more. Here also the monitoring will be there for the cloud-based storage as well as analysis. So examples of level 2 IoT system for tracking package handling. The system consists of a single node that is for package that monitors the vibration levels for a package being shipped. The device in this system uses accelerometers and gyroscope sensors for monitoring vibration levels. The controller services sends the sensor data to the cloud in real time using a WebSocket service. The data is stored in the cloud and visualized using a cloud-based application. The analysis component in this cloud can trigger alerts if the vibration levels become greater than the given threshold. So the benefits of using a WebSocket service instead of a REST service in this example is that the sense data can be sent in real time to the cloud. Moreover, the cloud-based application can subscribe to the sensor data feeds for viewing the real-time data. Next one is IoT level 4. A level 4 IoT system has a multiple nodes that perform local analysis. Data stored in the cloud and application is a cloud-based as shown in figure. So now here we may be having more than one node. These nodes will be communicated and the analysis component also will be takes place by using the IoT intelligence. Here the data which is you are receiving from the devices that is sensors, it will be stored in the cloud-based application as well as the database. Here we are going to have a observer node for analysis of the sense data. So for each and every device we may be having the monitor nodes which it is going to do the analysis based upon the analytics carried out in the cloud storage. The level 4 contain local and cloud-based observer nodes which can subscribe to and receive information collected in the cloud from the IoT devices. Observer nodes can process information and use it for various applications. However, observer nodes do not perform any control function. Level 4 IoT systems are suitable for solutions where multiple nodes are required. The data involved is big and the analysis requirements are computationally intensive. Now we will see the example for level 4 system, which is for noise monitoring. The system consists of multiple nodes placed in different locations for monitoring the noise levels in an area. The nodes are equipped with sound sensor and are independent of each other. Each node runs its own controller service that sends the data to the cloud. The data is stored in cloud database. The analysis of the data collected from various nodes is done in the cloud. The application, which is cloud based, is used for visualizing the aggregated data. Next we will see the IoT level 5. A level 5 IoT system has multiple end nodes and one coordinator node as shown in the figure. Here we are going to have a coordinated device which is going to coordinate with the end devices, whatever the collected data which will be there in the cloud based database, as well as the application also will run in cloud. Here the observers or routers endpoints which are in the local, they can monitor or coordinate with the cloud storage and the analytics carried out in the cloud system. The end nodes that perform, either it may be sensing and or for actuation. Coordinator node collects the data from the end nodes and sent to the cloud. Data is stored and analyzed in the cloud, and the application here it is a cloud based. In the level 5 IoT systems, which are suitable for solution based on wireless sensor networks, in which the data involved in big and analysis requirements are computationally intensive. Examples for level 5 system is forest fire detection. The system consists of multiple nodes placed in different locations for monitoring various physical parameters like temperature, humidity and carbon dioxide levels in the forest. The end nodes in these examples are equipped with the various sensors for monitoring temperature, humidity and carbon dioxide levels. The coordinate node collects the data from the end nodes and act as a gateway that provides internet connectivity to the IoT system. The controller service and the controller device sends the collected data to the cloud. The data is stored in a cloud database. The analysis of data is done in computing cloud to aggregate the data and make predictions. A cloud-based application is used for visualizing the data. The next level is IoT level 6. A level 6 IoT system has multiple independent end nodes that performs sensing and or actuation and they send the data to the cloud. The data is stored in the cloud and the application in this is a cloud based, which is shown in figure. Here we are having a device. The device, either it may be a sensor or actuator or it both a sensing and actuating device. This will coordinate with the centralized coordinator. The data whichever it is sent, it will be stored in the cloud database as well as application also will be run in the cloud. So the analysis of the sensed data will be takes place in the cloud. Here the monitors can observe locally through centralized controller for the data which is stored in the cloud as well as the analysis carried out in the cloud. The analytics component analyzes the data and store the results in the cloud database. The results are visualized with a cloud-based application. The centralized controller is aware of the status of all the end nodes and send control commands to the nodes. Example of level 6 IoT system, which is weather monitoring. The system consists of multiple nodes placed in different locations for monitoring temperature, humidity, and pressure in an area. The end nodes are equipped with various sensors such as temperature, pressure, humidity, COT levels. The end node sends the data to the cloud in real time using a WebSocket service. The data is stored in the cloud database. The analysis of data is done in the cloud to aggregate the data and make predictions. A cloud-based application, it is used for visualizing the data. So this about the IoT levels and deployment of the templates. So in IoT system, we are going to have various levels like IoT level 1, level 2, level 3, level 4, level 5 and level 6. In each and every level will be selected depending upon how many sensor nodes we are having, whether the sensor data has to be processed locally or at the cloud station. Next, whether the centralized controlling system is a centralized one or local or cloud based will be differentiated from one level to the another level. The applications usually will be existing in the cloud based. The database and analysis will be takes place in the cloud. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.